Hey everyone, I'm Tim Doiron, Vice President of Solution Marketing at Nokia, and I'm here today chatting with Venk Mutalik, a Comcast Fellow, and we're going to talk about the use of coherent pluggables in the Comcast network. Welcome aboard, Venk.
Tim, great to speak to you again.
So Venk, let's start with what is the first Comcast application for coherent pluggables in your network? And what are the benefits?
So there is a lot of benefits of coherent optics, but before we go into that, in Comcast, we are using your devices, the subcarrier devices, in multiple different ways. One of the things that I am using your devices right now is in a BiDi mode. So you have your 16 carriers. So we are repurposing a few of those carriers to go downstream and a few of those carriers to come back upstream. So in a non-spectrally overlapping way, we are able to use those devices on a single fiber. And single fiber is always very important for us because a lot of our existing access architecture is on a single fiber. And so this works really well on an already designed plant on which wavelengths are available so that we can use devices and systems that were built with previous technology, intensity modulation, perhaps, or even analog. I mean, like, if there was spots available, we could use it. We also use your devices in dual fiber mode, just like everybody else. So if you have a 400 gig device, then we could use the dual fiber solution, and then that works well for us as well.
Great application and great use case. As I think about where single fiber and this BiDi use case might be, what about form factors from the physical size of the pluggables and the devices they need to go into? And also, what about environmental conditions? Do those matter to these types of pluggables and in these types of applications?
Yeah, very much so. So the most important thing when we start using your devices in its form factor, we look at it with respect to CFP2, which is a slightly larger form factor, which has the same technology as a QSFP-DD, which is where we are moving towards as we move along. But both of those form factors have to be i-temp. So if you look at these devices are functioning from -40 to +85 degrees C. That's what is our specification. So it's a 125-degree variation. So it's got to work in the heat of Arizona, the cold of Minnesota, and all across. And so whatever technology we have, even the BiDi technology especially, we want it to be as resilient as possible. We're going to put them in some distant places with intemperate climate, and they should work fine. And that's what we have been proving in the last year or so. And we are moving very close to deployment as well. And the devices that we have, the CFP2s as well as the QSFPs, are already deployed in our field. And what we are doing for the first time is making available a fully i-temp coherent optics in the field. It's one of the first times ever that anybody has actually done it, and it's a pretty exciting thing for us to do.
In thinking about that application and the i-temp and the physical form factor and what you just mentioned, this is really reaching into your outside plant, right?
Yep.
This is the connectivity space getting to your fiber nodes or getting to your remote locations. Is that right?
Yes. So think about it. This is now going to be on a pole, or it is going to be in an underground pedestal, and it's 100 gigabits per second BiDi solution.
Right.
And it is going to be in an environmentally unconstrained form factor, right? An optical node, for example. That's the shelling where we will be. It's going to face the heat, the cold, the rain, and it works quite well. We have been very happy with how it is functioning, and so we look forward to deploying it.
Awesome. Hey, thanks so much, Venk, for taking the time to spend with us today. I hope the folks at the ECOC conference appreciate this and have a great show and a great rest of the event. And thanks so much for your time, Venk. Great to spend a little time with you again today.
Thank you.